Hello everyone, let's look at how to find the LCM and HCF of numbers using the tabular form or the tabular pattern. We have a question to attend. So using the tabular pattern or the tabular form, find the LCM and HCF of 84, 60 and 30. So quickly, solution. Now let me tell us, while using the tabular form, it means that we are going to draw columns. Are you getting it? So, and the columns are going to be based on the number of figures given to us. So if you look at the question, we have 1, 2, 3. 84, 60, and 30 are the figures. So we have 3 numbers there. So it means that we are going to draw 3 columns. Are you getting it? So let's go. We have 84. We have 60. And we have 30. So we are going to draw column in this way. And then the next thing is to think of any prime number that can divide these numbers. So I know the only prime number that will come to your mind is 2. So let's try 2. So if we go by 2, 2 divides 84, or 84 divided by 2 is 42. 2 divides 60 is 30, and 2 divides 30 is 15. So 2 divides all these 3 numbers without remainder. So we have come to the second row. So what prime number can divide these numbers? So I think 2 can also divide. So if 2 divides 42 to be 21, 2 divides 30 to be 15, and if 2 divides 15, there will be a remainder. If 15 is divided by 2, there will be a remainder, and we don't want anything that has remainder. So if there will be remainder, using this pattern, it means we are going to repeat the same number if there will be remainder. So 15 divided by 2, there will be remainder. So we'll bring down 15. Now we are on the third row. So on this third row, what number can divide these numbers? And we'll say is 3. So 3 divides 21 is 7. 3 divides 15 is 5. 3 divides this 15 is also 5. Now we are on the fourth row. So we have 7, 5, and 5. So at this point, 7 is a prime number, 5 is a prime number, this other 5 is also a prime number. So we'll now look for a prime number that will divide at least 2. At least 2 numbers. So if you say 7 should divide, 7 can only divide 1, which may not be wrong. But if we use 5, 5 can divide 2 numbers. Can divide this 5, can divide this 5. But it does not mean that if you use 7 to divide through, it's wrong. No, because your aim is to get the lowest common multiple, LCM, and it's not the arrangement or order of prime numbers. Are you getting it? So, to make it look nice, that is a prime number such that you can divide at least 2, we now use 5. So if 5 divides 7, there will be remainder. So if there will be remainder, we bring down the 7. 5 divides 5 is 1. 5 divided 5 is also 1. Now we have only one prime number, which is 7. So we'll now use 7. So if 7 divides 7 is 1. 7 divides 1, or 1 divided by 7, it can't. So if it can't, we bring down the 1. 7 divides 1, it can't. So we bring down the 1. Now that all of them are 1, we will now say we have come to an end. So therefore, what is the LCM and the HCF? So therefore, LCM of 84, 60, and 30 is going to be listing. If you want to find the LCM using this pattern, you are going to say, see the numbers you are going to pick. You are going to pick all the numbers outside the column. So multiply all these numbers outside the column. So let's multiply. This is 2 times 2 times 3 times 5 and times 7. So 2 times 2 is 4, times this is 12, and this is 60. 60 times 7 is 420. Quickly, what about the HCF? Now, I need you to understand one thing. Understand the HCF. H is the highest, C the common, take note, common factor, C. So what we are interested on in HCF are those prime numbers that are common. What we mean by common is any prime factor or number that was able to divide the numbers given, the 3 numbers given, at the same time or in a row. Any of the prime numbers that was able to divide these 3 figures in a row, or the 3 figures in a row, or at the same time, is what we refer as a common factor. Do you get it? So let's see the numbers that are common. So 2 here divides these 3 numbers without any remainder. So this 2 is common. What about this 2? This 2 only divided this without remainder, divides this without remainder, but you could not divide this. There was remainder here. So it means this 2 was not able to divide all the 3 numbers in a row. It means it is not common. So we are not going to pick it. Again, 3 was able to divide 21 without remainder, 15 without remainder, and 15 without remainder. It means 3 is common because it was able to divide all the 3 figures in a row. It means it is common. So, what about 5? 5 did not divide 7 without a remainder. So when 5 divides 7, there was remainder. But when 5 divides 5, there was no remainder, and when it divided this 5, there was no remainder. So it implies that it is not common, because it only divides this 5 and this 5. It did not divide 7 without remainder. It means 5 is not common. It did not divide all the numbers in a row. That is the meaning. What about 7? 7 only divides 7. It did not divide 1 and 1. It means that we are not going to pick 7, because 7 did not divide the 3 numbers in a row. So the HCF are only the numbers that divides the 3 numbers in a row, and these numbers are 2 times 3. Therefore, the HCF of 84, 60, and 30 is what? 2 times 3, which is 6. Simple? Thank you.